When we learned continuity, we saw that the function mod x is a continuous function. However, we saw just now that mod x is not differentiable at the point 0. Thus, it's clear that there exist continuous functions that are not differentiable. However, we now prove that there cannot exist differentiable functions that are not continuous. In other words, we will prove that every differentiable function is continuous. Theorem. If f from I to r has a derivative at c in I, then f is continuous at c. Proof. F is differentiable at c means that limit x tends to c f of x minus f of c divided by x minus c exists. And we know that limit x tends to c x minus c always exists. Now limit theorem tells us that limit of the product of two functions is equal to product of the limits. So because of this, we get that limit x tends to c f of x minus f of c by x minus c into limit x tends to c x minus c is equal to limit x tends to c of f of x minus f of c divided by x minus c into x minus c. And this is equal to limit x tends to c f of x minus f of c, which is again equal to limit x tends to c f of x minus f of c. So here it is actually limit x tends to c of f of x minus f of c. On the other hand, this quantity is equal to 0 and this quantity is some finite number. So because of this, the product of these two things is equal to 0. So which implies that limit x tends to c f of x minus f of c is equal to 0. In other words, we have limit x tends to c f of x is equal to f of c, which means that the function f is continuous at the point c.